In section 5.1.2, we're going to be interested in adding some new pieces of terminology that we'll use to help to describe sequences and how they behave. These two main pieces of terminology are going to be increasing and decreasing. Now over here on the side, you'll see that I've written down a bunch of different sequences to try to help illustrate these different points. So let's start by introducing this first piece of terminology, increasing. What does it really mean to say that a sequence is increasing? Well, here's what we have. If it's the case that a sub n, that is the number in spot n, is less than or equal to a sub n plus 1, that is the number in spot 1, for all values of n 1 and greater, that is for all possible spots, then I would call the sequence increasing. Notice that that's actually exactly what's happening over here on sequence A, as well as sequence B. These are both lists of numbers that have smaller numbers near the beginning and larger numbers near the end, right? That is, if I compare a number and the number next to it at any point in this list, I either get that the number at the right is larger or that the two things are the same size. We can distinguish these two lists by introducing another piece of terminology. We'll write this. We'll say it is called strictly increasing. That is, the numbers will only ever get larger if I just remove the ability for the two consecutive terms to actually be equal. So this is what I would have here. So I can see here that a sub n is strictly increasing, whereas b sub n is only regular increasing, because of the fact here that I have these kind of duplicate values that begin to occur within b sub n. Now decreasing operates very much the same way. You can see that c sub n and d sub n are decreasing sequences. The numbers in their lists seem to go down over time. And I can see here that in the formalized definition, I would know that a sequence is decreasing if it's the case that the number in spot n happens to be larger than or the same as the number in spot n plus 1, that is, the number after it. And again, this is definitely true for both lists C and D. We can add, though, to this and say that a sequence is going to be called strictly decreasing if it is the case that a sub n is greater than a sub n plus 1 for all n greater than or equal to 1. So we can add this extra term here of strictly decreasing if the numbers only ever get smaller. So notice c sub n would be an example of strictly decreasing, where again d sub n is just an example of regular decreasing since it has multiple values in a row that seem to be repeating. Now, ultimately, it's very difficult for us to say for certain whether or not A, B, C, and D are completely increasing or decreasing, because you'll notice that in each one of these statements, we have to make sure that this property of terms getting bigger or smaller or staying the same is true not just for some of the n values or some of the numbers in the list, but for all of the numbers in the list. This poses a slight problem later, because we'll see that when we try to verify whether a list of numbers, whether a sequence is increasing or decreasing, we can never do that by simply just looking at the numbers that we can see thus far. Because all it would take to, say, change a list like A from increasing to something completely different is to maybe say that maybe the next number in the list there is, I don't know, the number 0. Well, now that list is no longer always getting larger. So I have to be very, very careful when dealing with these definitions. I can't determine them purely from observing values. Although the best we could say right now is that each of these has the potential to be increasing or decreasing. However, it's also important to note that sequences like E sub n can definitely exist. You'll notice that in E sub n, sometimes the terms are going down, then sometimes they go back up or back down. It's kind of like they're bouncing all over the place. And so E sub n here doesn't really seem to fit any of the descriptions thus far. So these descriptions here of increasing or decreasing do not encompass all possible sequences, rather only some. But if a sequence does meet one of these conditions, and it can be called increasing or decreasing, we can summarize that sequences like that are called monotone sequences. So that's referred to as a monotone sequence. That's kind of a catch-all that means increasing or decreasing at the same time. It's also possible that we could refer to that as a monotonic sequence as opposed to monotone. Those words tend to be fairly interchangeable. And a sequence that is strictly increasing or strictly decreasing is ultimately going to be called strictly monotone or strictly monotonic. Now, we'll see that these words here are going to be used fairly often. In fact, we'll even have a theorem a little bit later in this section that's going to make use of exactly this sort of language. But we're going to have to start to take a look at now. How would I begin to demonstrate that a sequence is actually increasing or decreasing if that requires me to know something about all the numbers in the list? If my list goes on forever, that seems pretty difficult to do. However, in the next example, we'll look at 3 different techniques or approaches that we can take to determine if a sequence is actually increasing or decreasing for all of its spots.